Welcome to this video. This is Mr. Eicher. Question from the homework, number 11, a regular hexagon with apothem length 24 inches. Find the area of the regular hexagon. So, the center of the hexagon is right about there. The apothem is that length right there. Now with a hexagon, we actually are going to have to use trigonometry here. So if we have this triangle, that green triangle, once we know the area of that green triangle, then we can just multiply by 6 triangles. We know that the apothem is 24. So this length right here is 24. 24. This whole angle up here, here's the trick. Did one like this in class. The sum of these central angles right here, all these angles right here, the sum of all those is 360. And since it's a hexagon, you have 6 of those non-overlapping central angles, so you have divided by 6. That gives you one of those angles is 60 degrees. So, for instance, this top angle right here, that top angle of the triangle is 60, and these angles are congruent. So you have an equilateral triangle here. We talked about that in class. So if this whole top central angle up here is 60, then you'd have a 30 and a 30. The apothem is perpendicular, and erase that a little bit, erase that a little bit. And these angles would be 60 degrees. So if you need the side length, once you have the side length, it's a pretty easy question. If this length is 24, that would be the side opposite of 60. And if you're looking at that right triangle right there, you would have 24 is opposite of 60. So if you don't remember the relationship between 30, 60, 90 triangle, what you could do is say sine of 60 degrees equals 24 over, that's over the hypotenuse. We don't really want to know the length of the radius. We want to know the length of the side. So instead of using sine, I should have used, get rid of all this, I should have used tangent. Tangent of 60 degrees equals opposite is 24, that's the apothem, divided by, we'll call it A. Opposite over adjacent, the adjacent side. Solving for A, you would get A equals 24 over tangent 60. Tan 60. Putting that in the calculator, you would get 13.856 inches. So now you know that part of the side. So if you multiply it by 2, the whole side length would be 27.713 inches. And from there you have the apothem. Maybe I'll try to highlight that in a nice blue color. The apothem you have right here, and you have the side length right there, so then you could find the area of the hexagon. And I hope that is enough information that you could find the area of that large green triangle, that triangle right there, that big triangle right there, and find the area of that triangle, 1/2 base times height, and multiply by 6 of those. The next homework question is this one, find the area of the shaded region. We're going to have to take the area of the hexagon hexagon, sorry about the color change, area of the hexagon minus area of the circle, and that will give us the area of the shaded region. So to find the area of the hexagon, we're going to do something similar again. We're going to look at this triangle right here, for instance, which would basically be the same as this triangle down here. On this one, I'm just going to rotate it so I'm looking down at it like this. And you're told that the radius is 4.1. And in the previous example, we saw that this angle is 60 degrees, and likewise these angles are 60 degrees. So you have an equilateral triangle. That means that 4.1 also applies to the side length. Now that we have that, all that we need now is the apothem length. That was a little off. Apothem length. You have a 90-degree angle there. So you have a 30, 60, 90 triangle. There's 90, here's 60, here's 30. And 4.1, half of that is 2.05. That would be this half of the side. You have this is 4.1. So the side opposite of 60, you could use trigonometry, or you could remember that the side opposite of the 30, 2.05, 2.05 times square root 3. And that would be the apothem length. So now you have the apothem length. Now you have the apothem length right there, and you have the side length right there, and then you can use the idea that you're going to take one triangle, 1/2 base times height, and you have times 6 triangles. Since it's a hexagon, you have 6 triangles. And once you have that area of the hexagon, you can come back up and subtract out the area of the circle, which you have the radius of the circle given is 4.1. So find the area of the circle and take the difference. And that should give you, according to the pink answer there, 4.1 units squared. Thank you for watching this video. Let me know if you watched it, if you have any tips how I can improve such videos. Have a nice day.